Hello, everyone, and thanks for showing up. Hope you had a great RotaryCon morning so far. So our talk today is going to be about RotaryController, which is another part of interacting with an Android system, especially with the automotive. Before that, let me give you a small introduction about myself. I'm Taha Malas. I work for ParadoxCat, a company that's specialized with HMI and AI. In the HMI part, we're mostly in the automotive industry, as you can see from the list of partners and customers we have. And we also do some AI and 3D modeling. For the agenda of this talk, we're going to talk about what is the RotaryController by itself, from both the hardware and software part. And then we're going to talk about why we're speaking about this today in RotaryCon. And then if you're still interested, then we're going to talk about how you can utilize it in both from the app and platform side, and then potential use cases, and then outlook for the future, and where can this bring us. And of course, finally, we'll have a slot for questions. So please, if you have any now, note them down. We'll have a slot at the end. So what is it in regards of hardware? It's basically a knob, a central knob near the transmission lever that you have it near the driver to interact with the infotainment display mostly. And this should be the main display that you have in a car. The main actions that you'd get there is probably rotating clockwise and counterclockwise, which you can see from the curved arrows at the right and left. And then you have the 4 nudges in the 4 directions. And probably some other functional buttons, such as back buttons and home buttons, which are already supported by Android by default. And then you have other buttons, functional buttons, that depends on the manufacturer, like navigation, media, and some other stuff that you can add on top of the normal ones. That's in terms of hardware. Now, what does Android bring us, and how does it really collaborate us with to interact with this hardware? So we have the Rotary service that was introduced first in Android 11. So it was 3 years ago now. It's basically an accessibility service for handling the events that are coming from the hardware. The source code you can find is basically on the AOSP. From Android published, and they're always making some improvements there. So please make sure you always get this, the up-to-date ones. Now, why are we talking about it? Is it really that useful? And that's highly debatable, to be honest. Some people say it is, some people it's not. That's why I would like to get your opinion about it. Have you ever had it in a car of yours? You can, like, by showing of hands, if you have already got it in a car. Okay, so around the third or something like this. And have you ever used it? Yeah, almost all of the people that find it useful. Yeah, so basically the physical knobs are dating back from the start of cars, when you had like the radio and climate change knobs that are, yeah, I mean, when you did not have any touch screens. And then with the emerging of touch screens and third parties manufacturers, you had the touch display with the same old physical buttons that are not really integrated with the touch display. And then you have the big touch screens that are getting all the knobs away, and some people raise their voices that we need this physical interaction again, as it's more useful for them, especially on the roads when you have like a distraction in the touch screen, when you have to be pixel perfect when you have to interact with the touch screen with you. And this is also makes Android more complete and reliable to have more automotive cars run completely by Android. So how does it work for us from the app point of view? It's basically uses the old focus behavior when we had D-pads to interact with the Android system, even before touch screens. So it basically goes through the focusable views you have in your application. And the focusable views are defined with these 4 characteristics. It should be focusable, enabled, visible, and then has a non-zero width and height. And here we're talking about the properties themselves, not what you can see. So for example, if you have a view that's outside the screen, so basically maybe you translated the X and Y axis to the outer bounds of the screen, it's still visible from the Android part of view as it has this visible state true. So it's basically you have to look always at what you have at the layout inspector where visibility is visible, enabled is true, and all these characters are enabled. And with the standard behavior, if you don't have anything done or you did not integrate anything yet, so if you only have the RotaryController and you have your application, this is how it should look like. The examples we're showing now is from the Rotary Playground from Android, which it's also open source. So you can see here the standard behavior if you did not do anything. So you have your application already there, and you can see now, okay, sorry. So you can see the focus state is currently on the cards, then going right with the going counterclockwise. You can see if you want to go to the button, to the right button, you have to go through all the list. And then you have to rotate it through all the list and then until you reach the next focusable element, which is basically the button. And that might be a little bit hard because if you had like a huge or gigantic lists with 200 elements, for example, you would have to go through all of them until you reach the end and jump to the next one. That's why we have focus areas, which are coming from CarUI-lib, in which it would more structure your layout for slots or like different areas where you can nudge between them using the 4-direction buttons we already talked about. So you have 3 variations, so no matter what layout you have, constraint layout or frame layout, it would still be, also focus area is for linear layout, so it's like a really small change that you can do to make your layout more adaptable to that. And for example, here we have, we can see the left menu, which for us would be a focus area, and the other right menu would be another focus area. That would make the process more easier for the user himself. So now the new behavior with the focus areas, as you can see, you don't really have to, and if you go to the end of the list, you're stuck there as it's one focus area by itself, and only nudging right would get you to the right list. So in code, as we said, it's no matter which view group you have. For example, we have this constraint layout saying the cards layout, which we had on the right side, and you only have to do is, what we only have to do is change this constraint layout to constraint focus area. And yeah, we have also a couple of things added here, which is nudge left and nudge right shortcuts. They're basically, as you can see here in the next slide, yeah, so nudging like from this button, which is the first button in this layout, nudging right would get you to the rightmost button, And that would also be helpful if you have like a one focus area with 300 elements, for example, and then you want to reach the end of it, then nudging down or nudging right would give you a shortcut for it. So let's talk now about nudging out of a window. So for example, you're not only the only one in the display that's using this. So also like you have some system UI, for example, focusable stuff like these buttons on the top right side. So if you nudge, sorry, it's a little bit hard with videos. So as you can see here, if we nudge down and nudge up from our activity to the upper side from the system UI, it leaves the focus still there in our app. And the main problem is that Android does not really know how to handle this, or it like supports multiple focuses at the same time. And when you're focused, when the focus of your window is now changed, it does not remove the focus from your application. So that's why we have something called focus parking view. So the focus parking view is basically parks the focus with the fragment, with it's by itself, when you nudge out of it. And so it steals the focus basically, and for that it has to be a transparent view. It also should be at the topmost of your hierarchy, as it has to be like the best candidate to focus. And it's also measured as 1 by 1 always, so no matter how what width and height you put, it would be overridden to 1 by 1. And it should be also one focus parking view per window, but other than this, it would steal the focus at some points you don't want that to be done. So with the focus parking view added there at our hierarchy, we can see like nudging out of our window would have the focus inside in the focus parking view, and when we get back to our window, it would return the focus where it cached it basically. And in code, it's as this. So even if we set it to focusable false, or we set its height and width for 0, it would still get these attributes overridden to how it should behave. Now, another thing from the application side is direct manipulation mode. And as we said, that Android already provides lots of things to ease things for us. So for example, if you want this normal list behavior, you already got it, and you only have to change some of your layout structure to achieve that. But if you have more complex situation for sliders, for example, or for some time pickers, as we can see at later stage, you need something more flexible to get all the interactions from this hardware. And for this, you have two mechanisms, basically. One is the simple one, as Android calls it, which basically it also a little bit handles what you get. So if you press the center button like you can set that I want this activity or this view to be direct manipulation mode with this simple one. Then when you focus it and press the center button, you would receive the accessibility actions of scroll forward and scroll backwards, and you'd only get back of this mode when you press the back button. And that also has some limitations, as you could have seen, that you're still a little bit into the Android implementation, whereas in the advanced mechanism, you can choose when to enter that mode and when to get out of it, and you can get all the gestures by themselves. So a very quick example for this, where you can see here, we're at the time picker, we have the focus there, and once we click the center button, we have the selected state shown as we're in direct manipulation mode, and if we nudge up and down, I'm not sure if you can see how the time changes. And now, no matter how you get off no matter how you wanted to get out of the screen, you can't unless you press the back button again. So in code, it would be that you only listen for the key listeners, subscribe for the key listeners, and you would get the T-pad center, D-pad back and up and down. And that's for the nudges, whereas for in the rotation, it would be generic motions, and you can get to see if it's counterclockwise or clockwise by getting the axis value of this generic motion event. So another thing is off-screen nudges, which is, I think, overlooked. Yeah. So the off-screen nudges is basically, as we said, that you can nudge from right to left, but at some point you would end up with nothing to nudge to the right or left side. And in that, you can specify some intents or key codes in your AOSP to perform. So for example, in this example, we had the rotary playground open when we nudge right. So nudging right would open the rotary playground for us. And as we said, you have different capabilities there. You can do key codes, global actions, and you can also do intents on the off-screen nudges. Another overlayable resources from the AOSP side would be, as we said, the off-screen nudge arrays, global actions, intents, key codes, and we have the show heads-up notifications on bottom. So in general, the heads-up notification is usually on top, and you can do it on bottom, and that should be also in parallel with the system UI overlaid values. And you can also do rotation acceleration 2x or 3x per millisecond. So this is basically the interval in which if you have current rotation in one direction and you receive the other one in this interval, then it would count this as 2 rotations or 3 rotations. That would help also reaching or scrolling through big lists fastly. So from the OSP part, we'd also like to talk about how the rotary service nudges work. So it goes through an algorithm that's shown here. So at the start, when it's received a new nudge, it would look up if there's a heads-up notification in that direction. If yes, then it would focus it, and that would be the end. If not, then it would look for shortcut nudges, as we talked about before. So if there's like a shortcut nudge in this direction to go to the end of the list or some element, if yes, it would focus it. If not, then it would see if the nudge is enabled in that direction. And that's also one of the attributes that you can add to the focus area, where this focus area is basically does not allow focusing in that direction. If not, then it would perform the off-screen nudge that we already talked about. But if yes, then it would, if the nudge was disabled, then it would look for a defined focus area. And that's like if you have another focus area and that direction is defined, then it would focus it. If not, then it would look for views that are not inside any focus area with the geometry algorithm, in which it would find the best candidate to focus in this case. So what are the potential use cases or our outlook in this talk? So we could use in-vehicle games. So for example, you can do some 2D games and some maybe like shooting games. If you have like an aircraft with this famous game with the aircraft shooting aliens or something, it would be really fun to see in automotive. And it's also in heavy-duty machineries where the environment is really hard to work with touch screens as always. And also with other non-moving objects, for example, like one potential use case that we were talking about the other day is probably ovens, where it's really hard to always work with touch screens, and you would still need to, or you could always be wearing gloves while interacting with it. And that's where these knobs would be really helpful, and we would see more Android-operated softwares there. So for our references, we definitely use the Android documentations, the RotaryController service from the source code, open source code, and the Rotary Playground that we already showed. So do we have any questions with that?